Hello YouTube and welcome to the lesson about current. Let's first recap and see what the voltage was. We used an analogy. We said we have a bucket and this bucket is filled with water. And if you remember, the water level was our voltage. So basically, the higher the water level, the higher the potential to create a flow from, let's say, a hole that we put here at the bottom. I suppose this is familiar to you that if the column of water or the level of the water is higher, any flow that you have here at the bottom at a given hole is going to become stronger and stronger with the increasing of the height of the level of water. So, the analogy. The water level is the voltage and the current is this flow. As simple as that. So voltage is measured in volts and current is measured in coulombs per second or ampere. They mean the exact same thing. Coulombs per second, ampere. What's nice about coulombs per second? That it's nice that there is a much better analogy with the liters per second in a hydraulic system. And it really is easier to associate it with flow. Flow is something that has a rate. Something is going through something. So the flow you have here, the flow of water in liters per second, is the analog of coulombs per second in a system of a circuit, of an electrical circuit. The third thing that we're going to look at in the third lesson, the third unit that we already anticipated in the first one, is resistance. Now the resistance can be compared to the width of the hole. So given a certain resistance, to increase the flow or decrease the flow, or given a certain hole diameter, to increase or decrease the flow, we change the voltage. And we're going to see just that with our friend the bulb. You guys corrected me, it's not a lamp, it's not, it's a bulb. A lamp is something that has more to it than just the bulb. Well, I have two nice wires. Okay, stop wasting time. There we go. This is the voltage we are supplying. It's 14.4. Now we increase it. Now it's 22, and the number you see below here, it has as a unit, it has I. That means it's the current that is flowing through this circuit. And what does it say? 0.87. Okay. So we have almost 1 amp, 1 ampere of electricity, of current flowing through this circuit. Or almost 1 coulomb per second. So this guy can supply coulombs. And the coulombs, they travel through the wire, and when the supply is eight volts, let's say, when the supply is 8 volts, we have half a coulomb traveling every second. or 1 coulomb every 2 seconds. It's the same. So that's the flow. Current is measured in ampere, and saying ampere is the exact same as saying coulombs per second. Let's anticipate an equation for the next lesson. We're going to see that the voltage divided by the resistance is equal to current. This equation represents the relationship between how high is the level of the water, what is the size of the hole in the bucket, at the bottom of the bucket, and hence the rate of flow. You can see that if we take a numerical example, let's suppose this is 10 and this is also 10, well, you're going to have a flow of 1. If the resistance becomes higher with greater resistance, you're going to have less flow. Well, let's see if that holds true. If we put 100 here at the bottom of the left side of the equation, we are dividing 10 by a larger number. So we are putting a bigger resistance at our bucket of water. Bigger resistance, less flow. 10 divided by 100 is 0.1. There you go. Very, very simple. Big resistance, small flow. Well, what if we increase our voltage? We increase the resistance, but at the same time now we also want to increase the voltage. Well, the current is going to go back to 1 again. Slowly and smudgily. It's back to 1 again. That is an important concept. If you want a flow of 1 amp or a flow of 1 coulomb per second, you could have a big resistance with a big voltage, or a small resistance with a small voltage. That's very important. Okay. One last thing. Current as a standard that you will find in the electrical circuits and the drawings thereof goes from positive to negative. And what you will see actually in drawings is, for example, V, C, C, or VSS, and here ground. And the direction is this one. The physics behind it is a whole different story. This is just a custom. In schematics, they use this annotation. Okay, now you are almost an expert of the 3 units. Just a small disclaimer. We are using layman's terms. Okay, the lessons that we will have ahead of us will have more specific language, and we are both going to pay more attention to that. I will use it, and you will learn how to listen to it and be careful with that as well. Okay.